Hello students, the purpose of this video is to talk through rational functions. So a rational function, we've talked about its parent function, and we know that word rational, anytime we hear it, we want to think about a fraction. And so anytime we have some type of function that's in a fractional form, like 1 over x, we know that we're dealing with a rational equation. And we know some things about the graph. So if you look to the right of your screen, you see the blue curves. And we know some things that, like, as x approaches infinity, y values are actually headed towards 0, whereas when my x values are approaching 0 from the right, my y values are approaching infinity. So that's going in an upward motion and then, kind of coming down on my x-axis. Whereas when my x values are approaching 0 from the right, my y values are getting smaller, and as my x values are approaching negative infinity, my y values are getting closer and closer to 0. And so we want to understand this notation because you may see that I have these plus minus signs. All that means is you're approaching a value from either the right or from the left. And so I'm going to highlight here in pink. You can see that I have 0 from the right because if I'm coming from 0 in this direction, my y values are actually headed upward. But if I start approaching 0 from the left, as I notate here with the minus sign, then my y values are going down. And so sometimes we need a way to differentiate, are we coming from the right or the left, because they're doing different things on each side of that particular value. So in this problem here, if you look on the left part of your screen, I've given you an example. This is the function 1 over x squared. So as x approaches negative infinity, that means as my x values are going toward negative infinity, what is happening to my y values? Well, they're getting closer and closer to my x-axis, so that would be the value 0. And then as x approaches positive infinity, as you see in letter D, so as I'm going toward positive infinity x values, my y values again are getting closer to my axis value. Whereas when I approach 0 from the left-hand side, so coming from the left going towards 0, my y values are headed up toward positive infinity. And in fact, as I approach 0 from the right-hand side, the same thing is happening as my y values are approaching infinity. So what's the deal here? Well, we're going to want to get to a point where we can graph a rational function, but we need to think about what things do we need. So there's going to be 2 things that we need and 2 sentences we're going to want to remember. So I'm going to actually break this video up into parts. So this is part 1, where I'm going to talk about the 2 things that you need, which are intercepts. And in our next video, we'll talk about the other thing that you need, which are 2 asymptotes, remembering that these things are functions and that graphs hug asymptotes. Now, until you learn calculus, we'll really just be able to get rough sketches of these things. Calculus will give you some other stuff and applications, mathematical knowledge that will really allow you to graph these and have them down perfectly. But looking at intercepts, so we recall that y-intercepts are where the graph crosses the y-axis, and I know that the x value is always equal to 0. So when I'm asked to find the y-intercept, I'm going to plug in 0 for all of my x's and solve. So in this example here, I'm asked to find the y-intercept of this rational function. So for every x that I see, so x minus 3 becomes 0 minus 3 all over 0 squared minus 3 times 0 minus 10. I'm going to algebraically solve, and I am left with a final answer of positive 3 over 10. And this represents my y-intercept value. Now, when I'm looking at my x-intercept, we've learned that this is where the graph crosses the x-axis. So I am wanting to take my entire y value and I want to set that equal to 0. So I'm going to be solving for my x's. But here is the cool thing. When you think about an entire function needing to be set equal to 0, because I'm working with a fraction, as long as I get that numerator to equal 0, 0 over any number, regardless of what I get in the denominator, equals 0. So all I have to do is set the numerator equal to 0 and solve. I don't even need to worry about the denominator. So as long as I focus on that numerator, that is going to help me find what my x-intercept values are. Okay, and so you see I've taken my numerator, x squared minus x minus 6. I've set it equal to 0. I have factored it, and I was able to locate that I have 2 x-intercept values. So looking at this problem here, I have x minus 3 all over x squared minus 3x minus 10, but I'm only going to focus on the numerator, and I'm going to set that equal to 0, and I'm going to solve, and that gets me x equals 3. Only thing I want to check is I know that if I get a number in the denominator that makes it equal to 0, then that's not good either. So I'm going to really quickly in my mind, I'm going to check 3 in here to make sure that this thing doesn't make the denominator equal to 0. So this actually ends up being 9 minus 9 minus 10. So it ends up being negative 10. And that's okay. I'm allowed to have any negative value in the denominator. Therefore, this is allowed to be my x-intercept. Okay. Now again, remember these processes will find the only intercepts. There won't be any others. So doing this process will find everything that you need. Okay, so that's the step 1 to graphing. This is the end of part 1 video where we have focused on finding x and y intercepts for rational functions. Stay tuned for part 2 to learn further how to graph these functions.